Hello everyone. So in this pre-lecture tutorial, I'm going to piggyback off of the last pre-lecture tutorial where we learned about mole-mole problems. In that tutorial, we worked on constructing mole ratios using the coefficients in a balanced chemical equation to convert between moles of substances in a chemical reaction. Well, in this tutorial, we're going to be discussing mass-mass problems, in which case we're going to be converting between different masses of substances involved in a chemical reaction. And so you're going to see that mole ratios are involved in here as well. And it's similar to a mole-mole problem with a couple of extensions. And really the best way to demonstrate the differences is to actually go through an example problem and have you guys watch exactly how everything fits together. So in this particular example problem, I have sodium silicate. Okay, and sodium silicate is going to react with 8 moles of hydrofluoric acid, and I'm going to get these 3 products as a result of the chemical reaction. And I'm being asked how many grams of the sodium silicate are going to react with 0.8 grams of the hydrofluoric acid. So basically, I'm being given a mass of this reactant, and I need to know how much of the other reactant should react with this starting mass of the hydrofluoric acid. And so the way to begin is to go ahead and rewrite the starting information, and I'm going to set up a conversion factor. Now, the goal to any stoichiometry problem, and a mass-mass problem is a type of stoichiometry problem, is to be able to use mole ratios. And the only way that I can use mole ratios is if I'm working with moles of substance, not grams of substance. So the very first thing that I should do is take this number of grams of the hydrofluoric acid and convert it to moles of hydrofluoric acid. So I need the grams per mole, or the molar mass, of hydrofluoric acid. I'll leave it to you to verify, but basically that would be 20.01 grams of hydrofluoric acid per 1 mole. Now that I'm in moles of hydrofluoric acid, now I can go ahead and use my mole ratio. I want to convert between moles of hydrofluoric acid and moles of the sodium silicate. Now, if I look at the balanced chemical equation, then I already know that for every 8 moles of hydrofluoric acid, 1 mole of sodium silicate is involved in the chemical reaction. So if I cross out my units that cancel, I'm currently in moles of the sodium silicate. But I want to convert to grams of sodium silicate so that I satisfy the requirements of the problem. So I need to convert from moles of sodium silicate to grams of sodium silicate. And if I go ahead and calculate the molar mass, again, I'll leave it to you to verify, but there are 122.1 grams of sodium silicate in 1 mole of sodium silicate. So if I cancel out, basically what the setup is telling me to do is to take 0.8 grams, divide by 20.01 grams, divide by 8 moles of the hydrofluoric acid, and multiply that answer by 122.1. And if I do that math, I get 0.610 grams of the sodium silicate. Okay, now let's try one more example. Okay, suppose I have this reaction. And here I have glucose, and glucose is breaking down to this compound, which is ethanol, and I'm also going to get carbon dioxide. And the question is asking how many grams of the glucose are needed to form 7.5 grams of ethanol. So basically, if I have 7.5 grams of this substance, how much of this substance had to have broken down to get this mass of the ethanol? So the setup for the problem is still much the same. Basically, I'm going to start with the given information. 7.5 grams of ethanol. And the approach is still the same. I'm not going to be able to use the mole ratios within the balanced chemical equation if I don't convert these grams of ethanol to moles of ethanol. So I need to convert grams of ethanol to moles of ethanol. And so, once again, I'll leave it to you to verify, but basically there are 46.07 grams of ethanol in every 1 mole of ethanol. Then I can go ahead and use the mole ratio. I need to convert between moles of ethanol and moles of glucose. And if I take a look at the balanced chemical equation, there are 2 moles of ethanol for every 1 mole of glucose involved in the chemical reaction. So I cancel out the moles of ethanol. I'm currently in moles of glucose, but I was asked for grams of glucose. So I need to convert moles of glucose to grams of glucose, and so that would involve the molar mass of glucose. Again, I'll leave it to you to verify since we've already covered how to find molar masses, but that should be 180.2 grams of glucose for every 1 mole of glucose. And so if I cancel my last set of units, I'll end up with an answer in units of grams of glucose. So I would need to take 7.5, divide by 46.07, divide by 2, multiply by 180.2. If I do that math, then I should get 14.7 grams of glucose. Okay, so once again, try the follow-up assignment, which will give you an additional opportunity to practice this type of problem. Again, we'll have an application activity and additional review and reinforcement of this topic in class. If you have any questions, by all means email, and I'll see you guys in class. Have a good night.